Hi, my name is SIONG, Metro ID EC190991, the programmer of this project. I want to explain our coding here. First, we include SPI bus library, MFRC522 for RFID, and server for motor, and liquid crystal I2C for LCD 16x2. After that, we define our STI pins and reset pin, and define our server pin. Red LED pins, green LED pin also, and this is the number of push button pins, and this is the variable for reading the push button status. We define our access delay to a 2000 and deny delay at 1000. We create our MFRC 522 instance. Let's move to voice setup, and this is our voice setup code. We set our red LED and green LED as output and button pin as input. This is the initial serial communication, and this is the position of the LCD cursor. LCD will display the hello and door will lock together. This is the initial SPI bus, and this is the initial MFRC 522. This is attach the server variable. The server will turn to 135 degrees and delay for 7.5 seconds, and the server will turn back to 45 degrees and display put your card to the reader. Next, we move to voice loop. This is our main code here. If we press the button, the red LED and green LED will turn on, and the LCD display door unlock and goodbye for 10 seconds. After 10 seconds, the door lock and display scan to lock. The server will turn back to 45 degrees. Next, we move to look for new cards and select one of the cards, return back, and show UID on serial monitor, UID tag. This do the whole log size time. First, print the data to USB serial port. This hot code is for RFID. If you use the very card, the door will unlock and display welcome, authorize access, and green LED will turn on, and the server will turn to 135 degrees and delay for 7.5 seconds, and the green LED turn off, the server turn back to 45 degrees. If we use an invalid card, the LCD will display access denied and unauthorized ID, access denied. Then red LED will turn on and delay for 3 seconds and turn back to the main coding. That's all for me. Thank you.
Hello, my name is M.AMIN with the ID number of EC19094. I will show you the Proteus simulation of our group project. As there is no RFID module in Proteus, we use the virtual terminal to represent the RFID. So let's start the simulation. Initially, the servo motor is activated and the LCD shows hello and door will lock. So after 7.5 seconds, the servo motor is deactivated and the LCD shows door locked, scan to unlock. So let's key in the authorized key code. So when the authorized key code was keyed in, the servo motor and green LED is activated and LCD shows door unlocked and welcome. So let's get the invalid key code. So when an unauthorized key code was keyed in, the red LED is activated, servo motor stays still, and the LCD shows unauthorized access. So now I will show you what will happen when the push button is pressed. So when the push button is pressed, both red and green LED will light up, servo motor is activated, and LCD shows door unlocked and goodbye. So this will last for 10 seconds, and after 10 seconds, it will go back to the initial state. So basically, that's it. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good day. My name is AFIQ, matrix EA19007. I'm from group 6, project title RFID door lock system with timer. I'm handling the hardware development, and now I would like to demonstrate the hardware and how our system works. This is our hardware. As you can see, the design and connection. So first I would like to introduce the component one by one. First one is our power supply, which is the power bank itself. Provide 5 volt supply. And the second one is the I2C LCD, RFID scanner, Arduino Uno, breadboard, and as you can see, there is 2 LED, red LED and green LED, and the next one, 1 push button. We have 1 servo motor, 180 degree, a door latch or door lock, and 3 ID, which is only one is the authorized ID and the other 2 just act as dummy ID or unauthorized ID. Now I will run and demonstrate the hardware. So first I will power up the power supply, and we will focus on the LCD display and the door lock. Okay. Okay, as you can see, the LCD display, hello, door will lock, and in approximately 8 seconds the door will lock. Alright, as you can see, the door is locked, and the LCD display door lock scan to unlock. Alright, first I will try to scan the unauthorized card or the ID which is not registered within our coding. Let's see what happened. Access denied, unauthorized ID. The LED red light is brightened up and the door still locked. Next, we will try to scan the authorized ID which is registered within our program. Let's see what happened. The door unlock, welcome. The door is unlocked and the green LED is brightened up, indicate that the door is successfully unlocked, and within approximately 8 seconds the door is automatically locked. As we program, the user will be close the door in approximately 8 seconds. And the final card, which also unauthorized card, or the card is not registered with our program, you want to see after we already successfully unlock the door. If we use the unauthorized card, will it unlock the door as well? So we can see. Okay, access denied, unauthorized ID, LED light brighten up and the door still locked, which means the security is good and program as expected. Okay, next, how about we want to go outside after we already in? It's easy. So we already put the push button here to unlock the door. Okay, both LED brighten up, the door is unlocked, and the LCD display door unlock, goodbye. And within 8 seconds or 10 seconds, the door will automatically locked. As we expect, the user will close the door within approximately 8 to 10 seconds. Alright, so next I will explain which part will be put outside door and which part will be the inside door or inside the house. So first, these two components, which are the I2C LCD and the RFID scanner, will be put outside door, and the balance, the power supply, Arduino, breadboard, LED and push button, also the lock and the servo motor will be inside the house. Okay, so yeah, that's all. Thank you.